All right, so we're just example 3. Okay, y equals minus 2/3 absolute value, x plus 4 minus 1. Okay, and we're going to do 2 graphs on the same page, just like we did last time. We're on the same grid. Okay, y equals 3 absolute value, x minus 5. All right, let's see what we can do. Okay, so I'll do mine in 2 colors. Guess we'll do 1 blue. Okay.
Which one are we on, number 3?
Yep, number 3. Just picking up, literally picking up right where we left off. Okay, number 3. And, sure, I'll do green. Why not? And green. Okay, now, just remember, we need the shape and we need the vertex. Those are the 2 things that we need. Shape and vertex. Okay, I'm gonna call on random people to answer questions today. So, Zach. Yeah? Your choice. You may confer with your neighbor to check before you respond. Can you tell me the shape or the vertex of this graph? Your choices for shapes are linear or V. Yes, okay. Upside down V. Yes, you are allowed to confer, right? You get one, what is that thing called? Lifeline? You get 1 lifeline, right? You can have a lifeline. All right, so upside down V. Here we go. Olivia, which side has a positive slope? Which side has a negative slope?
So for number 3, that's the negative slope, and the positive slope.
Okay, as I'm looking at the shape, which side, the left or the right, has the positive or the negative?
Left is positive.
Mm-hmm. And the right side is negative. Okay. Nina, what is the slope number? Yep, 2/3. Okay. Next, Michelle, what is the vertex? Hold on. I know your question. Hold that thought. Yes, left 4, down 1. Okay, let's graph it. -4, -1. Okay, so vertex. And someone said, isn't the slope negative? It's actually opening down. The negative is what makes the shape open down. The 2/3 is how you're going to count it. So down to over 3, down to over 3. So on the right side, I'm counting a negative slope. And on the right side, I'm counting a positive slope. And notice how I marked my vertex, so I know where the center is. Yes.
So is this the parent function?
No, this is the actual graph. I didn't even draw the parent function this time. Because when you have a linear graph, you guys can count a slope from anywhere. The slope is actually the transformation. Or sorry, the dilation. Okay, so there is the blue graph. There's the slope that I counted. Okay. Next up. Jude. Sorry, I'll give you a second. You're busy writing. Okay, you can shape or vertex of the green one. You just give me anything because you're first up.
Vertex be 5, 0.
Yes, it would. 5, 0, so it's right 5. Lovely. I'm just going to go ahead and mark it while I'm here. Okay, there's my vertex. Okay, next. Nurav, shape. Line, V, up or down, and then I'll come here.
I think it'll be a V.
It is a V. Is it going to open up or down? Up. Question, McKay?
What is this green edges?
They should be around somewhere. Look in your baskets. If not, there's a bucket of rulers right up here. Okay. Okay. Sydney, which side has a positive slope? Which side has a negative slope?
The side on the right is positive, and the side on the left is negative.
Okay. And the slope, Max?
Slope would be 3.
Yes, 3. Okay. Graph away. Do, 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 do. Okay, wonderful. Okay, so I am using a random name caller up here, so you might get recalled before somebody, like, you might answer twice before somebody answers. I'll try not to. Yes. Okay, good question. So I'm going to clear the screen real quick. I'll put it right back up, so just give me one sec here. Okay, so when we are picking our shape, we actually only have a few things that we know. We have the parent function line, which is a first power, okay, which looks like this. Now, point slope form is the transformation form for a line. Notice that it has parentheses, okay? We are now learning our second parent function, which has the absolute value bars. That's what gives us the V shape, okay? The transformation form for absolute value is this one. So very similar. So what's the difference between them? Okay, the parentheses is what gives us the line shape. The bars is what gives us the V shape. Okay, and I'm going to go one more step. When you saw x squared in some of the Delta math pops up as pictures, x squared is a U shape. X cubed is this little squiggle shape, right? We have only learned this one, and we are learning this one right now. So it has to do with what you see in the equation and how you pick the shape from there. Does that answer your question? Okay, Sydney.
So x squared is the parabola, and x cubed is the perangula.
Perangula is more of a made-up name. We just call it cubic.
Okay.
Yeah, Emma. Say that again. Oh, okay. So this A value is the one that opens it up or down. So when A is positive, it opens up. When the A value is negative, that's what opens it down. All right. Clear it. Disappear it. Oh. Okay. So we are opening up. The slope is 3, so we've graphed it. Yeah? Okay. I think we're good. Yes?
What does the RX stand for?
Oh, that it's actually a right 5.
Oh.
That 5. I was just the transformation because this one is reflected. This one's reflected. This one isn't. Okay, you guys ready? Okay, this time we are going to see, we're going to move on from transformations, and we are going to write equations. Okay, how do you write equations? Pick the parent, and in this case, the shape, right? You got to pick the right shape. Okay? And possibly we have to check the domain just to make sure it's working. Shape, vertex, points, right? We got to pick out the things off of the graph. So here we go. Let's put our little sticker in here. First example. Okay. I'm going to draw a graph. You're going to copy it. We're going to write the equation of it. And I'm just labeling the points up here so that you can transfer them. Okay. Yes.
Do you have any more of the graphs?
Here we go. Yep. Okay. Adia. You here? Yes, right here. Okay. What's the shape? Line or V? It's a V, yes. I know, it was not a trick question. Okay, so it's an opening down V. Okay, so that means that it's the parent function. We got the shape to help me pick the parent. That is the absolute value of x. I've got to pick the basic equation. Okay. Now, looking at this, I know that this side has positive slope and that side has negative slope. Sasha, what should the A value be, or the M, or whatever number is in front? Yeah, -2/5. Negative because it's opening down. 2/5 because that's how I counted between the points on the graph. Right? I know that one side is negative and the other is positive. Okay. Olivia, what's the vertex?
2, 6.
Yeah, 2, 6. Okay. Put it together. Right, that's what I need. Okay, Claire, do you think you can put it together?
Yes.
Okay.
So -2/5.
Yeah.
And then in parentheses.
Let's go bars. Yep, absolute value bar.
X -2.
All right, pause. Duncan, what goes after that? We're missing, we have one number on the outside of the parentheses. What's it going to be? Yes, because the X is opposite and the Y is the same. Okay. Fantastic. Da, da, da. Man. No, we can do it. We got it. All right. Lots of graphs today. New graph. This is the last graph, though. Last graph. All right, there we go. Okay. Okay, here we go. Yes.
We don't have.
More graphs? I have.
Aren't there a bunch right there?
Oh, yeah, there they are. Here are the extra graphs. Question? What's your question? Oh, we're going to get to that. Can you pass this? Okay. Any other more graphs? Okay. Yes.
Why is the slope negative?
Because the graph is opening down. Okay. All right, here we go. Right. A piecewise equation. So now I'm connecting 2.1 and 2.2, right? Here we did regular absolute value equation. Now we're going to write a piecewise equation, okay, of the graph. Okay, but I'm going to just give you the equation in absolute value format. Okay. All right, write a piecewise equation of this particular graph. So the first thing we have to do is graph it. All right, McKay, where is the vertex of this graph? Yep, so -6, 6. So make that a plus, please. Shift it up. Otherwise, this will be ugly. Okay, so I got a vertex. Okay. Michelle, how is the graph opening? Up or down? Down. Yep. Okay, so it's going to open down. Okay. Allison, what is my slope number going to be? Yeah, so it's going to be, I'm just going to write 3 over 2. It is negative, and it's kind of both, right? Rise over run, rise, run, rise, run. Okay. I'm going to count it in both my directions. All right, so there's the graph. Now, that was just the starting point. I said write it as a piecewise. Okay? So we're going to pick the pieces. Pick the pieces. So I've got the left side is going to be my pink piece. The right side is going to be the yellow piece. Yeah.
How come it wouldn't just be a straight line? Because if you're doing like negative 3, 2, and then if you were to switch it and do positive, it would be going up 3 over 2.
Okay, so when I pick the positive slope, it's actually left 2, down 3. Left 2, down 3, which is minus minus, which is positive. Ask that again after we do this piecewise example. Okay, pink. Now I'm going to request that when we do this in the piecewise format, that we use point slope form, which is this one. This is the one I want you to use. Okay? Let's do pink. Let's do yellow. And then we'll write the piecewise thing right underneath here. We can make it fit. Okay. All right. Emma, what is the slope of the pink line? Yes, 3 over 2. Okay. Rayon, give me a point on the pink line. Yes, okay, negative 8, 3 is a good point. I'm going to switch it to negative 6, 6. Negative 8, 3 will work. Okay, but I'm going to switch it to negative 6, 6. Okay, write the equation of the pink line. 3 over 2x plus 6 plus 6. Yes, Duncan.
Say it were, say the point was like negative 6, negative 6. For the equation, the y part would be negative 6.
Yes. Was there another question?
Does it matter if it's negative or not?
Which ones?
Like 3 over 6.
Okay, so look at the pink line. What's the slope on the pink line? So it has to be positive here. Okay, yellow. Harini, what is the slope of the yellow line? No, she's behind you. What's the slope of the yellow line? Yes, negative 3 halves. Okay, we need a point. Sophia, point on the yellow line. Sophie? Who's Sophia? That's you. Okay, Sophia, sorry. Missed the E and the A. Sophia, what's the point on the yellow line? Negative 2, 0. Yes, that is a good choice. I'm going to make us choose negative 6, 6. Just on purpose. Okay, write the equation. X plus 6 plus 6. Whew, okay, I'm ready. I've got the pink. I've got the yellow. And now I'm ready to put it into the piecewise format. F of x equals. All right, so I'm just going to start with the pink. Okay, Henry. What is the domain of the pink line? Yes. Can you tell me in an inequality format instead? X is less than -6. Yes. Okay. Adam, the domain of the yellow piece.
Domain.
Mm-hmm.
Yellow piece. It would be X is greater than -6.
Yes. Okay. So notice here. Yes.
Doesn't one have to be like 4 equals to?
That's okay. So notice that I didn't actually include -6 anywhere, mostly because you have to look at it and be like, well, is -6 pink or yellow? It can't be both. It's got to be one because you cannot repeat your X's. Now, you can put it with pink or yellow, but not both of them. Okay, that's the only catch with the domain here. It's accepted either way. So the vertex is either pink or yellow, not both. Pink or yellow. And it doesn't really matter which. All right. Okay. Last step. We're just going to look at what we have here. And I'm going to just highlight my absolute value piece that I started with. I know you can do this graphically. We spent a lot of time doing this graphically. But notice how similar those boxes are. I went from a V shape in the bars to a line shape in the parentheses, but nothing else changed. That's it. Nothing else changed. All I had to do was change the parent shape. The parent shape went from a V to a line. The only thing I needed to be careful with was I had to make sure that this side got the positive slope. Check out the positive 3/2 to the left of the center. I just had to make sure the domain went in the right place. Let me finish my sentence and then I'll get you. Okay? The right side had to have the negative slope. Negative slope for the right side. That's the only thing I had to be careful with when I was changing the shape. Question.
What would happen if you did like, say we did the -2 and the 0?
Same thing. It wouldn't matter. You would literally just be looking to make sure that the correct slope is on the correct side of the equation.
Okay, so what was the point? Why couldn't we just switch the value?
You can. I wanted you to see that these numbers can be exactly the same. That's what I wanted you to notice. All right. I'm gonna. Yes.
So, if, like on a tester or anything.
Oh, I don't care. You can use any point you want.
Well, yeah, but can we just switch the bars to parentheses, or do we have to show our work?
Oh no, you just switch your bars.
Oh, really? Alright.
Yeah, that's but right. Conceptual understanding. You switch the bars. There's a lot of things you got to get right here. You switch the bars. You got to make sure you have the right slope with the right domain. Means you have to know where the vertex is. You have to know whether it's equal to or not equal to. There's a lot of other things that go into just switching the bars to parentheses.
So you would still recommend solving it? No.
I would recommend understanding why you're doing it and then just doing it. Okay, I'm going to give you one to try, and then this is it, and then we're going to switch to practice. Okay, this time, no graph. right? No graph. Write as a piecewise. As a piecewise equation. Right, y equals. Doot, 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 doot. Okay, that's it. That's all I'm going to give you. Right, notice I'm scaling back on how much information you have to work with. I'll give you a little bit of guidance. Figure out the left side and the right side. And then we can put it together. Okay, tip number 1. Sasha, or sorry, Maddie, tell me whether this graph opens up or down. Up, okay, great tip. Just because I didn't give you a grid doesn't mean you can't, like, envision the graph in your head, guys. You can still do that. Okay, that's tip number 1. This graph opens up. Tip number 2. Sophie, what's the vertex?
3, 1.
Yes. Nina, tip number 3. Which side has a positive slope?
So the right side has a positive slope and the left side.
And it's going to be 2 because I'm looking at it. Okay. Looks as though I've got a point and a slope for each line that I need. I didn't have to graph it. I can, like, know those things in my head. I'm like, right? You can do it. It doesn't have to be a beautiful graph. You could just do a little bit of information. Okay. Anybody? I'll take a volunteer this time. Look at all those hands. I'll go, Duncan. Can you give me the equation of the left side?
Yeah, it should be, I think it should be -2, parentheses, x minus 3 plus 1.
Okay. Equation of the right side. Yes, Henry.
Y equals 2, parentheses, x minus 3, parentheses, plus 1.
Yes. Okay. Yes, that is beautiful. Okay. I had somebody ask me, can I distribute those things? Yeah, if you want to. That's fine. You don't have to, but you could. All right. Negative 2x plus 6. So it could be negative 2x plus 7, right, if you distributed this. Or 2x minus 5. Okay. I guess I'll just copy this over. Okay. Okay. Domain. Who can give me a domain for the left side? Wait, we'll go Sydney because you just answered.
X is less than or equal to 3, and you can choose to make it or equal to either one. I just chose to make it less than or equal.
Yes. Okay. For the right side? Yes, Sasha? Okay. All right, now for the biggie. How did we get 3? Hold on. All right, we'll go here. Duncan, tell me. How did you pick 3?
Because that's the point with the graph, like the two different things are
Because this little line that goes down the center of the graph called the axis of symmetry is where the graph is split. Whew.